On May the 20th, 1990, the Hubble Space Telescope sent its first image to Earth. This photo turned out to be 50% sharper than images from ground-based telescopes. In August of that year, Hubble made one of its first discoveries, capturing a glowing 1.3 light-years diameter elliptical ring of gas around the center of the explosion of supernova 1987A. This occurred on the outskirts of the Tarantula Nebula in the Large Magellanic Cloud. These were just the first of thousands of miracles that the Space Telescope has shown mankind in 30 years. And how many of them the successor of Hubble, James Webb, NASA's largest and most powerful telescope worth $10 billion, will be able to show. The James Webb Space Telescope is an unprecedented mission that's on the verge of seeing the light of the first galaxies and unlocking the mysteries of our universe, says NASA Administrator Bill Nelson. The first pictures from the Hubble's successor are already here. What did the new Space Telescope see in deep space? James Webb is the largest extraterrestrial telescope in history. Its primary mirror consists of 18 hexagonal segments with a total width of 6.5 meters and a weight of 40 kilograms. For comparison, the Hubble mirror is only 2.4 meters in diameter. Thanks to this, James Webb will be, according to various estimates, tens or hundreds of times more sensitive than its predecessor. The primary mirror of the telescope is covered with a layer of 24-karat gold. It was made from beryllium. This metal is only 1.8 times heavier than water and covered with the thinnest gold film. Its thickness is only 100 nanometers, which is 1,000 times thinner than the thickness of human hair. So the total amount of precious metal in a giant telescope is just over the size of a single golf ball. This choice is based solely on functionality. Gold reflects red light better than any other metal. This gives spacecraft mirrors a reflectivity of 98% compared to the standard mirror's reflectivity of 85%. Thanks to this, the telescope will be able to capture the infrared light of galaxies located at a distance of up to 13.6 billion light-years from Earth. For this reason, it's called a window into the past. It takes time for light to reach the Earth, so we'll see the universe when it was still very young. The list of the first targets of James Webb contains 286 applications, which in total will take about 6,000 hours of observing time of the telescope. It includes already discovered exoplanets, disks around young stars, very distant galaxies, quasars and protoclusters, galaxies in the local universe, solar system objects such as comets, asteroids, trans-Neptunian objects, centaurs and ice giants, as well as the Milky Way's stars and nebulae and satellite galaxies. So on December the 25th, 2021, an Ariane 5 rocket with the world's largest and most powerful space telescope on board was successfully launched from the Kourou Cosmodrome, located in the French department of Guyana. Before launch, the two wings of James Webb's primary mirror were folded together in order to fit into the rocket's nose cone. Moments after shutting down the engine of the second stage of the James Webb launch vehicle, it separated from it and deployed the solar array. On the first day of the flight to the halo orbit, the first trajectory correction maneuver was performed using the observatory's engines, and a high-gain antenna was deployed. During the first week of the flight, the telescope deployed all layers of the heat shield and extended a 2-meter support tower, separating the optical system from the main part of the observatory. For the second week, the telescope deployed the optical system so that it began to gradually cool down to operating temperatures. Then, James Webb's team began remotely deploying the hexagonal segments of the primary mirror, the largest ever launched into space. The first side was finally deployed on January the 7th and the second on the 8th. By January 24th, 2022, James Webb had covered more than 1.5 million kilometers on its way to its new home, L2, the largest Lagrange point between the Sun and the Earth, around which it will orbit. After nearly a full month in space, the Space Telescope has completed a series of equipment deployments and has gone from a tightly packed launch configuration to what looks like a real observatory. The apotheosis of this stage was a selfie taken using a special lens aimed at the primary mirror of the observatory to help with the alignment process. The powerful cameras of the telescope captured the flower of the Webb mirror opening in space. The picture turned out modest, but it did not disappoint the team. Next, NASA had to go through a painstaking process of fine-tuning the position of each segment to turn 18 separate images of the universe into one large, super powerful mirror. After aligning the mirrors, James Webb took another selfie to show off its new look. And finally, here it is, the first long-awaited star. Image taken by the James Webb Space Telescope shows part of the mosaic created over a 25-hour period starting on February 2, 2022, at the beginning of the process of aligning the 18 segments of the James Webb Space Telescope mirror. Strictly speaking, the resulting image is made up of more than 1,000 individual photographs. However, if you look at a picture made up of hundreds of images, you'll notice that not one but a whole scattering of stars, 12, stand out there. In fact, there are exactly 18 bright points, according to the number of segments of the primary mirror of the James Webb, each of which at that time actually worked as a separate mirror. So as a matter of fact, the image does not show different stars, but 18 versions of the same one, HD 84406, located at a distance of only about 260 light-years in the Ursa Major constellation. According to the characteristics, it's very similar to our Sun. The light emanating from it hit various spots on the infrared camera lens, reflected from different surfaces. After its mirror alignment was completed, Webb took a stunningly sharp image of the star. Its name you can see on the screen. The star is the target switch for Webb. The red filter enhances visual contrast. Although the star is in the center of this image, distant galaxies and other stars can also be seen in the background. On March the 11th, Webb's team completed the phase of adjustments known as the fine phasing. In this key stage of commissioning an optical telescope element, all optical parameters have been verified and tested. The team did not find any critical issues or noticeable contamination or blockages in Webb's optical path. The observatory is able to successfully collect light from distant objects and transmit it to its devices without problems. On April the 28th, the agency announced that the James Webb Space Telescope has completed its setup phase. The latest image from the James Webb Space Telescope shows an amazing view of the Large Magellanic Cloud, a satellite galaxy of the Milky Way. We've never seen such a neighboring galaxy before. The Large Magellanic Cloud in the infrared range of the James Webb Space Telescope looks clearer than ever. Focusing on the star field of the Large Magellanic Cloud allowed Webb scientists to test the telescope's performance. What we see today are only the first technical photos at various stages of setting up a space telescope. We're on the cusp of an incredibly exciting period of discovery about our universe. The appearance of the first full-color images of Webb will be a unique moment for all of us. It'll make humanity stop and marvel at a spectacle we've never seen before.